we'll see it surely in the HDFS session. So guys, this is a very basic architecture about Hadoop. Please look at this architecture. Means I can say I'm showing the architecture, it's very overview. Will go. Means you can say this architecture is from a height of 40,000 feet. Will go deeper and deeper and deeper to closer to this. I'm unmuting you all. I want your thoughts on this architecture. How exactly you can give points, what you can understand from this architecture diagram. If there is any disturbance from your side, you can mute yourself by your options, and you can unmute whenever you want to speak. Anybody want to grab the chance, or you want some time to think about this?
So Anish, what I understand is the green portion wherein all slaves and master lies is Hadoop framework wherein all the slaves and the masters are the same entity.
I'm muting.
Master being the server wherein all other slaves machines are controlled. If any of the tasks are, assigned to any of the machines or any parallel processing needs to be done, master can control that event to the machines wherein the processing are being done within that Hadoop framework, and the final output or the end output are returned back to the user, which is the smiley at the end. This is something which
Very
I
good.
understand.
So Prince, one question. So did you give all these points directly looking at this architecture, or you have earlier read about Hadoop?
No, this is something which I understand from the pictorial diagram which is there in front of me.
Okay, great, appreciable. Anybody
I think
wants to add more
smiley
points
at the end is the user.
Yeah, that smiley, that smiling face is user's smiling face.
Okay, and I think that's why the smiley of yours comes into the picture as well. And you're the Hadoop man.
Anybody like to add any point in Prince explanation? Please ping me, I'll unmute you. Or should I take the name? Okay, let's give one chance to firstly Guru Prasad. Yeah, Guru Prasad.
So I won't be adding much to what Prince told. So what I understand is, like, whenever you submit a task to the master server, the task would be divided equally into, it will be shared to the, it will be divided and it will be processed by parallel computers, like slaves, for example, right? And with this, the processing time will be reduced, and the user will get results as soon as possible. Like, they will get results in a fraction of seconds, I guess.
Okay.
So this is what Hadoop is doing.
Good. Quite good. Let me unmute now Ahmed.
Slave, each slave is cluster in Hadoop architecture, and I think each cluster has portion of data, so it can fasten the process of analyzing the data. As a map reduce can get each portion of data from each cluster.
Okay. Okay, good. That's all, almost many of the points is covered. Shweta, would you like to add something? I have unmuted you. Unmuted you.
Yeah, actually, whenever a task is submitted, the data is distributed across all the slaves, and the master is the machine which contains the meta information of about all the slaves where the data is stored. I have a prior knowledge, so
No, that's fine. You can say.
so it will whenever the client requests. Yeah. Whenever a client requests any information, the master will collect the data from the respective slaves where it is stored. So basically, master contains the meta information about all the slaves,
Mm-hmm.
and slaves is where the data is getting distributed. The HDFS works at the slaves part,
Mm-hmm.
and the
Okay, good enough.
master retrieves the data according to the client's requirement.
Right. Perfect. So guys, almost all of you have touched almost all the points. There are few things that I want to sorry. There are few things which I want to change is your terminology firstly. So client submit a job. Use this terminology instead of task. Don't use word task because that is a terminology that is used in Hadoop. That is because task is done by the slave. So your complete work is called a job. Client submit a job. Master divide the work to all the slaves, which in turn do the task. In turn process the data or do the work. So say for example, the client has submitted some work. So I'm giving you one by one, first step, second step, third step to more and more deeper. So firstly, overall, when a client submit any work, that is called a job. Master divide the work to all the slaves who do the work simply in very simple language. So what is this master and slave? All the masters and slaves combined to them is called a cluster. They are connected together. This is called a Hadoop cluster, typical cluster of Hadoop. So master, there is only a single master and there can be n number of slaves. This n can be up to 4,000 in Hadoop 1, 12,000 in Hadoop 2. So master, there are some processes running on the master and there are some processes running on the slaves, all the slaves. So when client interact with the master, client interact with one of the process with the master to submit its algorithm. So say for example, if client submits some algorithm, okay, then the algorithm will go to slaves and process the data there. So ultimately master is, you surely have heard about this particular relationship of peer to peer and master and slave. So here we are using the master slave terminology where master give the work and slave do the work, simply like that. So you can imagine, so instead of if we talk about your conventional system, there only one machine was there in the picture. So that one machine was itself is a master or itself is a slave, and it was only doing all the works. But here you have n number of slaves. Say for example, today according to your requirement you can have 100 machines, 100 slaves. So all 100 slaves will be working for single work. Now what's the power of Hadoop? Power of Hadoop is parallel processing or distributed computing. So all of this 100 slaves will be working, doing the same work. Even I should say the part of the same work. A part will be done by slave 1, a part will be done by slave 2, a part will be done by slave 3. Let's go a little more deeper inside this. Before giving any work, before submitting any algorithm, firstly we need to put some data inside Hadoop. How exactly we put the data? So when we copy any data, as rightly explained by Shweta, like say suppose here the client's first request is to copy some data. So when client is writing some data, imagine say I'm having a file of 100 TB. So let me explain you pictorially. This is one of very important concept. Please try to understand it. I don't know whether I think I am having one picture ready for this. Let me check the picture if I am having. No, I think I don't have that picture ready with me. Let me explain you. So guys, this is a very crucial, very important, very fundamental thing. If you understand this, then only you'll be able to understand the next level things. So guys, this is my Hadoop cluster. Suppose this is a very big file, so 100 TB file that I want to copy into my Hadoop cluster. So Hadoop cluster will be having surely one master. Suppose let me make master like this, and n number of slaves. Let me draw a diagram a little more clear so that it will be good for you to understand. My drawing is a little bad, so please excuse me for that. I'm trying my best to explain you this. These are the slaves. Now guys, how exactly the data is stored inside Hadoop? How exactly the data flows? Even for the flow, we'll see it later. How exactly the data is splitted? So say for example, if you want to store your this 100 terabyte of file, it won't be stored as it is. The file will be splitted into some chunks. The file will be splitted into chunk of 64 MB. These typical chunks are called blocks, file blocks. So the file will be split into 64 MB blocks. Now when the client copy this data, this file into Hadoop cluster, it will firstly interact with the master. What master is having? As correctly explained by Shweta, it's having metadata, where slave stores the actual data in the form of blocks, data blocks. And I should like actual data in the blocks, in the form of blocks. Okay, understood, no issues. So the huge file, that is 100 TB file, will be divided into 64 MB block. Can anybody tell me how many of the blocks will be there? Oh my god, I opened a mistake. This clip manager, I don't know. CALC. Oh, again the calendar. calculator. 100 TB. My maths is not that much good. Can anybody tell me? 1000 upon, oh sorry, 100, 1024 GB, 1024 into 100 upon 64. These many blocks will be created, right? TB to GB, GB to MB. Yeah. So guys, these many blocks will be created of this single file, and this particular block, suppose after interaction with the name node, it will suppose go here. Let me write like this. Oh my god, it's very tough to make picture without mouse. I'm expressing, suppose this is your data block, the red one. This is your data block. The same way you will be having thousands of the data blocks on each and every machine. Then I should not draw with this, just try to understand by this only. So your file is splitted into 64 MB blocks. All the blocks are splitted across all the machines in the cluster. Suppose block 1 is here, even let me write it like this, block 1, block 2, block 3, something like this. I can write block 1 is here, block suppose 2 is here, block 3 is here, block 4 is here, block 5 is here. It's little bit random, but on what factors it depends where the exact block goes. I'll explain this, but first try to understand that your file is splitted into blocks. Okay, your file is not stored as it is. You will be having these many number of blocks. 64 MB chunks of 100 TB file will be splitted into these many blocks, and all the blocks are stored, if I say this is our new cluster, so this are randomly stored over all the slaves, first year, second year, third, fourth, fifth, sixth, seven, eight, nine, till thousands, all the things. Okay, is it clear? Got two big smileys, 3, 4. Perfect. So guys, this is the mechanism of HDFS that provides you the functionality to the map reduce, that you will be having distributed processing, you will be having parallel processing, you will be having distributed computing. So just imagine the client submit, when client submit the algorithm will process first block here, second block here, third block here, fourth block here, like that. So you will be having parallel processing. Since your data is parallelly available on multiple slaves, so data is parallelly processed on all the slaves. Now how exactly you will come to know where is exactly my all the blocks are stored? If client want, say for example, overall cluster, how exactly what the point of integrity, how exactly you can integrate all your data blocks. The master is there, which is having metadata. Master stores the metadata. So what information master carries? Master carries all the information about all the slaves, all the blocks, all the files. Master is having all the information. So master doesn't do any work. Master doesn't store any data. It stores just the metadata, and it takes the work from the slaves. So this is about the data blocks, the basics of the data blocks. Let's go back to our that PPT. So that is the very basic architecture about Hadoop. We'll go more deeper inside this. Let's come to HD.